Hello, welcome to Live Coding with Gerph. This is episode 5, I think we're on now. What we're doing here is we're going to write some code which makes an ARM disassembler for RISC OS, implementing the Debugger module, and we're trying to make sure that this all works using RISC OS Pyromaniac. So far we have a number of things implemented which are going quite well, really. And where are we actually up to? We have we have a number of commands implemented. If I just go back on my issues here, it's not showing me the board. Let me have a look. Project board, disassembler project. Here we go. So have a look at this. We can see that we've got a number of things that have been done. This is the recent set of things that we implemented. Particularly last week we did star memory A and added the CI build of the code. And we've got a lot of little things to do here. Today we're going to have a look at debug operations. So let's move that into in progress and have a look at what it says. So this has got a number of different commands. There's break set, break clear, break list, continue, and debug. Almost certainly I'm going to implement these differently to how it was done in RISC OS Classic. We're just going to see what's going on. Right. I just had a message saying we couldn't add in any video. It's now showing. Good. All right. So yes, we're going to implement some commands, and I will almost certainly be doing them differently to how everything was done in RISC OS Classic. And the reason is I'm not sure that it was done particularly well. Also, I haven't really paid a huge amount of attention. I think it goes through the OS breakpoint SWI call, which precludes it from being used as a for SWI calls and things, so we can't use it in SVC mode. So I'm going to do it differently, and hopefully it will still have similar functionality, if not a little bit more useful. Hopefully. I mean, it might not work. Yeah, we'll have to see whether that does work. So today we're going to need to add those commands, and I don't think I'm going to get much else done. Unlike the other sessions where I've largely known exactly what I'm going to do and how to do it, this time I'm a little unsure, and the reason is that I'm starting out with trying to do debug code that isn't quite the same as what I would normally do. I don't find that these commands, I don't think they're particularly useful myself, so I've never really used them, and I've never really thought about what they're doing under the hood. So I'm going to play with that. I've already realized that one of the things that I was going to do, so I was expecting to implement the breakpoints as the breakput instruction, BRKPT. So this is an ARM instruction that's in later versions of the ARM specifications, and it can pass in a number to say what type of breakpoint it is, and we can use that as part of our information about what we're going to do. But RISC OS Pyromaniac didn't implement it, and it would crash Pyromaniac. So yesterday I went and added a little bit of support for that, so that it calls the prefetch abort. So that will at least make things a little bit more easy for us to use. So let's start doing some things, shall we? Let's have a see what we can actually do. There's going to be a number of things we'll need to do with this. So let's have I'll just talk through what I'm going to do. So we need to add in new commands: the debug, continue, break list, break clear, break set. Those commands are all going to be relatively simple, I think, to implement the commands, and then the actual bit underneath them is going to be a little bit more difficult. So yeah, I think I'm going to start out with break set, then break clear, and break list. So we'll actually do the management of breakpoints. and we'll see how that works. And then we can worry about the extra commands here. So let's go back over here to our editor. And yeah, last time I was saying I was going to do it the other way around. So let's swap these around. It was definitely more readable having it like this. A bit more, yeah, that's okay. I might be able to give myself a bit more room in the top. Yeah, I think I can give a bit more room in the top. This will be fine. Okay. So first thing, let us go and define the not errors, the breakpoints commands. So I'll go down to the command list here, and or just pinch show regs. Copy paste. There we go. So break set. Now pretty much I'm assuming this takes one argument always. And we use break set value or register, same as we did with init store and the others. Okay. And this is going to set a breakpoint on an address. Okay. Break set. And we do clear as well, which takes exactly CLR, isn't it? Not CLEAR. Really isn't much point in it being a abbreviated thing, but oh, star sets. That doesn't look very good, does it? Star break set sets a breakpoint. Yeah, that's better. Break clear clears a breakpoint on an address. And break list doesn't take any parameters, so we can zero off these two. List the currently set breakpoints. List and clear. Oh, actually we'll call it exactly the same as the command. Right, and we need some commas on the end of this to make sure it's a valid list. Okay. Now we need some implementations for these. So let's spin to the end. Oh, those are the SWI calls. I wonder if I should split the SWI calls out to another time. And I said it's most likely init store. So let's just copy the init store code and put that here. So this is going to be break set. And there isn't a default, so we don't need to worry about that case. We just need to deal with this. So we read an argument string and oh, bad syntax. Okay. Breakpoint there. We don't need to worry about that's actually doing the implementation. So breakpoint set on value. That sounds good. Oh, actually what we could do here is we could make it return an OS error. If we make it return an error, we can then just make it return there. So the idea here is we've got break set, which is now just the parser, and then we call into a library that we're going to implement for setting the breakpoint. And let's do another one for clear, which has exactly the same parameters and returns clear. And then we have another one for list. List doesn't take any. Oh, actually, we've got limits. I don't need those, do I? I don't need limit at all. So that's just one thing I can remove. That's not terrible, I suppose. Actually, we don't even need value for this or any parameters. We just do break list. And we don't need to take any parameters at all. For consistency, I think I'll leave it returning an error. So we can actually say, I couldn't do anything or something like that. Okay. So, here I've used a error message that I haven't defined. So let's define that. Wherever the errors are. Where's the errors gone? Here we are. Here's errors. Okay, comma. Error break bad syntax. Bad syntax for break points. It'll do. We can always tidy up the error messages at some later time. Okay. So we've now got an implementation of the parsers. We just need to do the library. So let's just build it. And yeah, we'll just have it. It'll try and load the debugger, but we won't actually be able to do anything because there's errors. Ooh. Obviously there's errors because value may be used before it's been set. 309. Ooh. Oh, that's a bug in the earlier code. Oh dear. That's interesting. How might value be set? So value gets set there. Oh, so it's thinking that it could come through to this interactive section, but it can't because interactive is set similarly there. Let's not worry about that for now. I can tidy that up later. That's the problem with these warnings. You end up if you've left warnings in, you end up with problems where you don't know whether that's something you've just introduced or it's something different. Okay, where were we? We were in the middle of doing break set. So it's telling me that limit isn't used, so I missed one to delete there. There we go. Oh, duplicate definition of break set. Oh, yes, that one there. This should be set. That should be set clear, and this should be list. There we go, breakpoint list. All right, so now we just need to define a header that says what these interfaces are. Let's go to the top. Hash include breakpoints.h. Right, so create a file called breakpoints. Oops, B-R-E-A-K points. There we are. Oh, that's not the right one. There we go, file header. Breakpoints deals with adding and removing, managing the breakpoints in the ARM code. Date today, 21st of July, 2024. Still weird that it's 2024. If nadef breakpoints h, define breakpoints h, so that guards us so that if we include the file twice, we don't get it doing anything. And let's define what a breakpoint looks like. Struct. There we go, a breakpoint. This is what our internal structure of a breakpoint will look like. So we need to know a uint 32t for the address, uint 32t, the value, or old value. Every breakpoint is going to have a number so that we can actually find them all. So I'm going to go and give this an int number. Yeah, that sounds sensible. What else do we need to know about it? We know its value, we know its address, and we know it's got a number. Okay, that seems like, I think that's everything we need to know. So, let's define some headers. So we need to include kernel.h because we want to use kernel loss error. Oh, in fact, we want to use, oh no, kernel os error star breakpoint set. And it takes a uint 32t of the address. Okay. There's going to be one that's clear as well. Yeah, clear, spelled properly because this is a library. And another one for list, which doesn't take any parameters. Okay, so breakpoint set a breakpoint by writing a booked instruction into memory. Parameters address equals the address to break at, and returns pointer to an error or null if all was well. Okay, now this definition and this definition are pretty much the same, and that one's not much different. So this is clear. Removes a breakpoint by restoring the old instruction. Breakpoints. This is list, isn't it? List. List all the breakpoints to the screen. Right. Okay. So that's how they're going to work, how they're going to be structured. Let's actually take a copy of the entire file, and we'll just create a new breakpoints file up here in the C directory. Breakpoints. So exactly the same file. Get rid of the guards, leave the include, and add in. Oops, went too far. Breakpoints. We don't need to have a declaration of that. And now we can start implementing. So, no, not capitals. So no. Okay. We're going to want a list of breakpoints. So static breakpoint, not breakpoint, yeah, breakpoint, that's what I wanted, breakpoint underscore t. Oh, who wants a list of them? Oh, do I do it as a linked list or do I do it as an array? I think I should do it as a list. Breakpoints. We'll do it as a list. So if we're doing it as a list, I need to, not that file. Header, there we are, here's the header. I need to define a next pointer in each of these. Breakpoint next. So there we go. Those are the ones that are all related to, so those three are all related to the actual breakpoint data, and this is part of the list management. There we go. Right. Oh, let's get rid of that file. I accidentally opened it. Right, here we go. So setting a new breakpoint, we want to go and add it to the list. That's easy enough. I say it's easy enough, but I haven't actually done linked list management for quite a while. I want to find the end of the list. I want to create a new list entry, so breakpoint equals calc size of. Right, so we always will allocate the correct size of block there. BP to address equals address. Ooh, we need to get the value, don't we? So uint32t value. This is the value we're going to read. Value equals. No, pointer to it. Address. Read the address. So I'm reading the value here before we allocate the memory, because if that address that they've asked for the breakpoint to be on doesn't exist, we will end up crashing at this point. Maybe we should validate it. Let's add a fix me in there. Maybe we should validate. Oops, should validate this memory first. But the crash is okay because it won't be destructive of anything. It'll just exit the command and we won't have allocated any memory, so we'll be safe. We won't have leaked anything. Assign the, sorry, not value, old value. Why is the huge cursor? I have 5 different monitors here, so if I have a small cursor, I regularly can't find it. So that's why I've got a very large cursor. I've 1, 2, 3, 4, 5 monitors visible, so you can't see them, but I can, and I lose my pointer very, very easily. I can also shake it as well, and that makes it go bigger, but that's why. Old value equals value, and I've forgotten what the other things were. Breakpoint to, oh, we need to have a number. We need to have a breakpoint number allocated to it. So let's have a static next number. Next BP number. That's next number will do. And we'll start at 1. I'm starting at 1 because I don't want to use 0, because almost certainly we'll at some point want to use 0 to be something special, like not allocated. So let's start at 1. Breakpoint number equals next number, and next number can be incremented. And then breakpoint next equals. So I can either add it to the head of the list or I can add it to the tail of the list. If I add it to the head of the list, I suppose it doesn't make a lot of difference. It'll just mean that the more recently added ones will come up first when we search. It's fine. We'll just make it the head of the list. In fact, I'll make a note about that. Adding to the head of the list, because it doesn't matter when we search for them, whether it's fast or ordered. There we go. And then breakpoints equals BP. All right. This block here is all adding we also want to actually change the memory. Ooh, and BP could fail, couldn't it? If BP equals null, we need to return not enough memory. Create an error for that. And in addition to reading the value, we should also write it at the same time before we do the calc. So, which probably also means we want to know what the number is first as well. This bit is adding the breakpoint to the list, which means I shouldn't have. Really not paying attention here. That is part of the global. This one here is part of this block. Maybe these should be two different functions. Just for now, I'm going to leave it as it is, and because we could have a add to list and we could have a sign breakpoint, which would actually be. All right, that's a problem for later. Right now, we're just going to give it a new value here. So this is replacing the instruction. Yeah, it could be better structured, this. Press the wrong key and cause it to scroll. We also need to know the number we're going to use, which is next number plus. And we need to know the number because we're going to put that into the breakpoint instruction. Equals big key t plus number. And of course, I don't remember the bit sequence that we use for breakpoint instructions. bkpt instruction arm. Breakpoint, that might be the one to look at, or one of the ones to look at. Let's have a see. I need to know the actual bit sequence it uses. Let's put the word opcode into there. See if that one does any better. Nope, that's the same blooming document. All this lot came up last time when I was looking at it. That might be the right one there. Architecture reference manual. Let's search for the word bkpt. There are 49 of them. 53 of them, sorry. No, that's the behavior. So the interesting thing about this is the behavior is enter abort mode. We're running in ARM state, and then enter the high vectors up here. That's what we're going to do. It also, on the later processors, sets the debug mode flag to say what it was doing, and the fault status register, the FSR, specifically the IFSR for instruction fault status register. However, we'll get to that in a little while. Instruction encodings, breakpoint. Okay, yeah, that's what I thought. The actual value of the breakpoint is split between two different parts, because who doesn't love instructions being added after an instruction set has been created? So, what is that value? Let's have a look, shall we? All Python, right, so that is OB 1110 0001 00 Oop. Yeah, that's right, 0, 0, 1, 0. Shifted left 20. What's that in hex? E12 something. And it's also got some of the bits at the bottom set. 0, 1, 1, 1, shifted left 4. That's also a binary number, please. Okay. So, go back up here. Let's just hash define bkpt bracket number is OX E12122370 or number, right, the low 4 bits are in the first 3 bits, so that's and OXF, come on, or number shifted right by 4 and then shifted left by 8. So that'll chop off the bottom 4 bits and then put them all the way up here. I've got my or in the wrong bracket in the wrong place there. Bracket should be there. And close that. Right. One breakpoint instruction macro. Oh, no, that's not what I wanted. bkpt instruction bracket number. Also, just whilst I remember, we should probably define the limit. Define bkpt limit as 65535. Oh, not space, sorry. 65535. If next number is greater than breakpoint limit in order to reuse them, we'd have to go all the way around the loop, the instructions. So that's not a big deal. I'm not dealing, so this could also be, a breakpoint could also be encoded as thumb instruction as well, in which case it only has 8 bits. I'm not dealing with that in the slightest. That could be an extension in the future if somebody wanted to have a play with that. Coding of the BKPT instruction okay. So that's going to set the breakpoint, which is good. Next, we need something to clear it. So we're going to first need to go and find the breakpoint in our list, because we need to restore the instruction that was there. And then we're going to need to unset the instructions. Missing an missing an arg from calloc. Oh, calloc takes 2 parameters, doesn't it? It's a number of elements and the count of them. Number of elements and the size. Yeah, thank you. I'll just leave a note saying star. I will if I can actually type it in the right window. There we go. Yeah, I was implementing calloc just yesterday, and I'd forgotten that it takes 2 parameters. Shows how little I write C these days, doesn't it? Hello to Lazy Alpaca as well. We've got a few people here. We've got 4 people now. This is quite good. Right, so breakpoint, we need to find the breakpoint, and we also need to, when we're doing an unlink, we need to remember what the last one is. Last B. Let's just quite last P, and that's going to be breakpoints. Find the breakpoint in the list. Oh, that's a good point. I'm going to leave a fix me note here. We should check that the address isn't already breakpointed. Because if we have 2 breakpoints there, we're going to get ourselves confused, and let's not do that. So, I mean, strictly, I think this will probably be quite safe, but for now, I think it's probably a good idea for us not to have multiple breakpoints at the same address. As I say, confusing. Find the breakpoint in the list. So, for BP equals breakpoints, Mr. Bracket, whilst BP is set and BP is not BP2 address, So keep going while yeah. BP. Oh no. Hang on. Last P equals ampersand BP2 next, comma BP2 next. No. Oh, that's the entire loop. There's nothing else to do there. If BP is null, no such breakpoint. Okay, so we've found the breakpoint. Now we need to, which do we want to do first? Do we want to remove the breakpoint first, or deallocate or unlink it first? We want to unlink it first. No, we don't. No, we want to remove the breakpoint first, because if the breakpoint removal causes an exception, it will remain linked. And we'll still know that it's there, and so when it gets executed, we'll still be able to handle it. Yeah, that's right. That's what we'll do. Just a quick part of my thought process that I've not mentioned. I'm using I'm encoding the breakpoint number into the breakpoint instruction. Partly that's because we can, which is a nice thing to be able to do, and partly it's because knowing which breakpoint has been triggered might actually be useful in the future. We might be able to do behavior that is like, if you hit this particular breakpoint, do automatically go and print this register out or something like that, which would be quite useful. I'm not intending on doing that right now, but that's what I was thinking about. We could do it based on checking the address, but if we just check the address, that doesn't work if the code has been relocated. Code doesn't generally get relocated in RISC OS when it's already in memory, but in particular, the instructions that are used as part of the variable setting codes, if you do set sysvar, and then you give it a code variable, that code will be copied elsewhere. And so it does matter for those sorts of things. So that's the reason why I'm doing the encoding there. It may actually be completely irrelevant. We may not need to do that in the future. But it seems sensible since we do have an encoding for breakpoint numbers. I don't actually know whether it's available in 64-bit ARM. And strictly in 6502, which is the other one I was thinking about trying to do at some point, the breakpoint is actually your error handler, so I'm not sure how you might handle it there. Anyway, for ARM32, we'll see what we can do here. So now we want to remove the patched instruction. So let's do that. Star BP to address equals BP2 old value. Is that really all we need to do? Yeah, I think so. I'm just going to leave a note. Should we check that the value is as expected? I don't know if that's useful or not, but I'm just going to leave a note there rather than trying to implement it right now. So that's unlink. Remove the patch instruction. Unlink from the list. Last p equals bp2 next. Free bp. We're now unlinked and freed. Okay. List all the breakpoints to the screen. If anybody's spotted something I've missed, please do shout up, because I'm sure I will have missed something here. This is kind of where having the code committed live and actually pushed would mean that somebody could actually check it whilst I'm doing stuff and not just have to look at my screen. We're not at that kind of collaborative level yet. I did try that. Anyway, let me not get myself too distracted with that. Right, so breakpoint t start list. So new user started and just said, can you explain a bit more about what we're trying to do? Right, okay, I'll just do a quick summary of this. So this is a module for debugging on RISC OS, which is an ARM system. And I am trying to write the code that handles breakpoints at the moment. So there's a number of commands: break set, break clear, break list. So I'm implementing those commands, and we're going to patch the instructions and then we'll list them. So this is basically the management of breakpoints. How we actually handle the breakpoints when they're executed, we'll do in a little bit, but we're just handling the breakpoints. So I'm writing this on macOS. It's going to run on an emulated system that I wrote called RISC OS Pyromaniac. And so we can see whether it's going to work properly, and it gives us a whole bunch of debug out showing us what went wrong. At the moment, we're just writing the C code that does the breakpoint handling. And then in a little while, we'll be writing a bit of the assembler that handles the abort handling and how we trap that. And there might even be a bit of Python handling where I have to fix up the emulator, because I suspect, well, I'm pretty sure there are sections I have not implemented in the emulator just yet. So that's what we're doing. I hope that helps you. Please feel free to ask some more if you've got any other questions. Either myself or one of the other people on the channel may be able to answer you. Not a problem. So, yes, at the moment I'm trying to list the breakpoints that we've got. So let's try and do this. Let's just try and go through the list. Go through the list and report what the breakpoints are. So BP2 whilst BP2 next. Oh, that was rubbish. That's BP equals... Oh, I've forgotten what. Breakpoint. Yeah, sorry, got distracted, and now my brain's gone and forgotten what I'm trying to do. It's all very easy just to say, yes, you just do this, and I've already forgotten what the just is. Right, so printf breakpoint number %. -5i, so print it left aligned at address number 08x, as a long, and old value was that, and we might as well try printing out the disassembled instruction as well, because we can. So we've got breakpoint BP to number, BP to address, BP to old value, and then I have to go and disassemble it. Disassembly is in row disk, RISC OS disassembly file. Oh, hang on, let me look at the header, it'll be more useful to me. Debugger disassemble. How are they different? It's really useful. I haven't documented my functions, isn't it? Oh, it just passes in 0. Well, okay then, that's actually what I want in this instance. So let's just copy that into here and we'll go to this. So yeah, debugger disassemble. Oh, hang on, did I say that could return null? Can it return null? Haven't documented it. Oh. No, it can't return null. Okay, that's good. Debugger disassemble of word is BP to old value and address is BP to address. Okay. What do we think? Is that going to be like working or not? Let's just compile it and see. Build the module and then try and load the debugger. Oh, right, okay, well that makes sense. We haven't actually added the new file to the make file, so it doesn't know to build it. Makefile module. Oh, these are oddly indented, aren't they? Wonder why that is. Let's just tidy that up, shall we? Probably spaces here. Yeah, it's just space alignment. I'm not going to worry about it. O dot breakpoints. Points. Yeah, that didn't work in the slightest. Lots of problems. Oh, lots and lots of problems. Oh, okay. Well, let's go back to that. So this is in h.breakpoint. Oop, wrong one. This window, please. H breakpoints. So we need to include int.h. What else do we need in here? I think most of the rest of the errors are all related to the fact that the structure doesn't exist. Although that one is because I haven't included studlib, I think, in C breakpoints. Let's have a look in that. Yeah, so we haven't included studlib.h and we haven't included studio. So we won't be able to print anything. That will give us errors as well. Is there anything else, any other calls in here we need to use? Calloc, free, printf. All right. Oh, and we want to include the module header because we want to get these errors when they exist. Let's do that. Include modhead.h. Lower precision and wider context at line 47. LU. Do that. Ooh, just noticed. These are parameters from, come on, click there please, from the macro, so I should put brackets around them. Otherwise, if you try and do arithmetic operations, it will fail. Spurious NDIF found, that's left this NDIF on there. Ooh. Actual type int mismatches format %s. Number, address, value. Oh, that's because it's invented Debugger disassembler, because I didn't include rodis.h. Include RISC OS disassembly. I'm regretting having that name. Not enough memory isn't defined yet, and I've missed some semicolons yet again. Line 57. 57. Not enough memory, that's fine. Not enough memory. 60. Yep, missed a semicolon there. And 95 illegal types for unary. Did I define the address as being a? I just defined it as uint 32. Okay, so I need to go back here and I need to recast that to be a uint 32. There we go. All right, let's define some of these errors then. No, not enough memory and no such breakpoint. Here's the module header that's got the error definitions in. Not enough memory. Not enough memory. There's actually a standard error number for not enough memory, which I could probably use. No such breakpoint. I can't remember what the error is though, so I'll just try RISC OS kitten. That's actually what I want. New errors. No memory. Okay. Case insensitive. No mem. Okay. I thought there was a standard one for not enough memory. Okay, well, I'm wrong. Shows how much I remember. Unless anybody happens to remember that there is something more appropriate and I can add it in there. Anyway, that should do the job. We can now go and try compiling it again. Dave says, weird, we created one for ePage. Maybe I'm just thinking of ePage then. Which is entirely possible. Oh, so this has not built the mod head before that, so I just need to go and update my module header to say not only does the veneer need mod head, breakpoints needs mod head as well. Ooh! It compiled and linked, and now it's taking a very long time. There we go. Right, we started up. So, help debugger. Break set, break clear. Where's break list gone? Did I forget break list? I'm sure I remember writing it. Break set, break clear, break set again. Yeah, that's stupid. Let's try that again. Right. Try again. Help debugger. Break clear, break list, break set. Good. So break set 8000. We should probably print a message saying that we've done it, shouldn't we? Let's do that. Printf breakpoint set at address. I know I went out of my way to not use printf earlier, and now I'm doing it. Yeah, doesn't matter. So break clear. Actually, memory I 8000. Let's have a look at the instruction. Breakpoint number 1. And if I do a break set on 8004. Nope, not help debug. I didn't mean that. I meant that one. Breakpoint number 2. That's cool. All right. So we have breakpoints that can now be written to memory. Let's list them and see if our list works. Apparently, I didn't step through the list properly. Oh dear. How did I not do that? I'm just stupid, I guess. Oh, yeah, just doing BP to next doesn't do anything. It should be, come on, BP equals BP next. And we printed out the old disassembly, which is quite nice. That's quite good, actually. Let's do that then. Okay. Um, 69. That's probably my printout, isn't it? It should be LX there. Oh, clicking doesn't always actually click. Something to do with the way we're capturing the screen, I think. Okay. Why have I got? Oh, because we terminated it, so it didn't save the history. Break set 8000. Break set 8004. Break list. Looks good. They're both printed out. They're both doing the right thing. So, break clear 8004, please. Now list. Clear 8000. List is now empty. Set 4 and set 0. Oh, no, that's clear. No such breakpoint. That's cool. That wasn't what I was trying to test, but it's done the job. Set 8000. Now list them again. And they're 3 and 4. Cool. Now, that's quite cool, isn't it? Yeah, that's working. All right. So, if we do *go and try and run one of those breakpoints, so if I just do memory I 8000 plus 4, type. Right, there we go. Go. So run that code. Abort on instruction fetch, breakpoint at 8000. So that's the extra code that I wrote last night to make it actually handle that, because previously it would just go unknown interrupt and crash. But now it knows that it's a prefetch. So yeah, when the breakpoint instruction is hit, it triggers the prefetch abort, just as if the memory wasn't there. And then you're meant to decode the instruction and decide what to do about it. Or decode what the problem is and decide and see what to do about it. Yeah, that's what's meant to happen. I think this is a good point to checkpoint everything and commit the code, because that is all working. I mean, we can't actually do anything with it at the moment, but it is working. Oh, actually, can we do show regs? So we do show regs here. I might need to make my window a bit bigger here. Right. So show regs is telling us that that's interesting. There's a lot more space there than I'm expecting. Might be a bug in that, I think. Yeah, I'll have a look at that later. That's a problem for me. So here we go. We've got the registers here. We've got the address that the link had on it. The PC is set correctly, and we're hitting this breakpoint. Now, what we could do here is we could actually report what that breakpoint, what that instruction should have been, which would be quite cute. So let's have a think about that. Yeah, that would be nice to do. The other thing that's interesting here, so if we just kill off our debugger module and then reinitialize the standard debugger module and do show regs, we get a different output. Oh, that's why there's extra spaces on this. It's because it's my new code. Yeah, of course. I'm stupid. Yeah, we see that the code looks very... Oh, no, it doesn't look similar at all. That looks like garbage. Interesting. Okay, so the registers are coming out wrongly, and I know why that is. That is a bug on... I think that's a bug in the Pyromaniac implementation of that. But we also print out here the IFSR, the instruction fault status register, and that has a number of different conditions on it. That's not something that we can actually read from the operating system. It's not actually returned at the moment. It's possible that that could be a useful thing for us to set up. So maybe we'll do that in the future. But IFSR could actually be something we could return in the new modules debug code, the show regs code, to actually return what that is. Yeah, let's make sure we can do that, shall we? So let's close this and let's add it into our to-do list. Add item. Report IFSR or DFSR in the *show regs output. Come on, pull it up, please. Thank you. Edit. In *show regs, we report the PSR and the fault from OS read sysinfo 7, I think. I think it's read sysinfo 7. It would be nice if we could report the IFSR or DFSR when there is an exception. Let's call to report this. Okay. There we go. Update the comments. Make it into an issue on that project. And there we go. Right. So I won't forget that one now. Oh, no, hang on. Whilst I'm thinking about it, let me just set some labels on it. That is a enhancement. It is not a feature parity thing. So, oh, actually, it is a feature parity thing because it's feature parity with Pyromaniac. Yeah, we'll put down parity as well. What the heck? There is an interesting thing of now there are multiple versions of RISC OS, multiple distinct implementations of RISC OS. So what are you using as the baseline? That's a big question that just, I suppose it also hits almost all of open source as well. So, you know, it's something to ask people and see what people think of that sort of thing. Anyway, back to the code here. What were the things that were... that's what I was doing. I was going to go and commit this code and say we are done on that now. So let's status. No, status with files, please. Add c/breakpoints and h/breakpoints. Yeah. Commit Mosaic. Added the handling management of the breakpoints list and star commands. Now have star break set, break clear, break list implemented. When we hit a breakpoint, we just get a prefetch abort. Breakpoints aren't showing up in the disassembly. Okay. Yes. Seems good. Okay. Let's push that. Oh, I didn't mean to put that on master. I meant to put it on a new branch. Checkout -b. Give me a branch. Breakpoints implementation. Git branch. So I accidentally committed it to master and I wanted it to be on a branch. I don't want it to be on master. So there's a number of ways that I can do this. I could delete the master branch in my local copy and then check it out, and it would bring down the version from the server, which is I think what I'll do. So git branch delete master. Now check out master and just see, yeah, we don't have that on there, but we do have it on breakpoints implementation, so we can push that now. So if anybody wants to actually see this live, oh, I'm on the taskboard here. You'll go back to the project. Here we are. This is GitHub/Gerph/DARM. It's the location for it. And you'll see there's all sorts of bits in here. There's even some README and stuff, although it's the original README. I should probably update that so that it reflects the current project, I think. But you can see there's a bunch of branches that have already been merged and our breakpoints implementation there. Okay. Right, that's 2 hours 10 minutes. We've got about 20 minutes until I'm going to take a break. So what I'm going to do in that time, I think, is when you do star memory I, so let's go and just show this. Here we go. Come on. Break set 8000, memory I 8000 plus 8. It would be really nice if there was a comment here that said what the original instruction was, because then we can actually have it like listed, and that would be kind of cute. So what I'm going to do for that is we're going to modify some of the code that we've got for the instruction parsing. if I can work out how. So it should probably only be in memory I, not in dump I, because it won't matter in dump I. Go to roadies here. I don't know what's happened there, I got confused. Disassemble word and debugger disassemble. So that's probably fine because that should just disassemble what the word should be, nothing else. But do I want the comments to be added at the end of it? I'm not sure. Oh, I'm all confused now. Because comments could actually be a separate thing. I don't know. I don't know. If I look in memory I, which is our code that does disassembly, that's the dumper. Here's the disassembler. And it gets passed in the data accessor from where the start is and where the end is. Oh, this is something I've thought about for you. Well, I've kind of done in part of how the disassembly code works in the Python. But if I could provide a function that is an annotate function, we could actually append to the end of the line an additional annotation. Yeah, I think that's a fair way of doing it. So let's go to the header and define what that's going to look like. So see, I could have data accessor provide. No, I don't think that's the right place to have the annotation function. It should be a separate thing. Type def const char star bracket star annotator function, and it should take a address and should we take an instruction word uint uint 8 underscore t star data and size. A function to call to provide an annotation for a given address. Data. I'm feeling a little bit uncomfortable with this one, but I'm not feeling too bad. I think it's probably right. If it's not, we can always change it in the future. So let's pop down, don't want the accessor code. So disassemble file will never have any annotation. Oh, a disassemble file could have an annotation. No, it can't have a breakpoint annotator, can it? Annotator func. Oh, annotator for. Yeah, I'm feeling that seems okay. Let's annotator function to provide more annotation for line. Or null. Copy that and then go into the memory I file. Where's disassemble memory gone? Somewhere down here, isn't it? Dump memory, dump file, disassemble memory. Put that there. Get rid of that. Take away the semicolon. Right. So then we want to pass this into the disassemble stuff function as an annotator. Disassemble stuff is here. No, that's dump stuff. Disassemble stuff. They're really well named functions, you can tell, can't you? Oh, I wanted that comment as well, didn't I? Oh, actually, I can copy it from the header that I was just in. Here we go. Annotator, annotator. Something like that. We're not using training, so let's do it that way. There we go. Bum, bum. Let's try and start annotation. If annotator, ooh, I don't want the new line on the end of that, do I just want to print the string? If annotator function equals bracket. I've forgotten the syntax I was using. Address, data, size. Address. The data is in what happens to be exactly the same syntax as this here. And copy that segment there. Down over here. And do that. If we oh, I missed a bracket. Yeah. Oh, no, I didn't. Why did you put it there then? Don't know what happened there. That's weird. Have I? I might have missed something somewhere then. I'll wait until I've compiled it and then it'll tell me what's wrong. Oh, I also want a const. That might as well just be in here because there's no point in assigning it outside. If annotation this is probably going to look a little ugly, but I'm not going to worry about it at this moment. And then finally, write the new line. Okay. So that'll give us the annotation, if we've got one, but we've got to write the annotation function in a little bit. Here's dump stuff. Don't care about that at the moment. File accessor, disassemble file. Disassemble file, there we go. So that needs to pass in a null on the end for the annotator because it doesn't have one. Okay. This will probably break. I'm not sure what is going to be wrong with it, but yeah, this worked. Memory i8000, does it crash? Exception, undefined instruction import. Good. Okay then, so let's stop that. Debug trace block. Much better. Right, what were we doing? So we were in disassemble stuff. We'd done a little bit in the floating point emulator. Oh, because we tried to branch into, because the actual fault was that we'd undefined instruction. So it goes into the floating point emulator to try and decide what to do about it. The failed code was there. What? This almost certainly means that I've just not got things linked properly. Make clean. Let's just start again from... No, sorry. RISC OS AMU. Clean. Right. Good. And then rebuild it. Probably means that one of my files hasn't been rebuilt with the new definitions in it. No, failed from a clean build as well. So definitely means I've screwed up something. And this is the function call that I was doing in the annotation code. It's definitely in the place of the annotation code, but we don't have an annotator yet. I'm a little confused. Did that actually clean things, or did I not clean them properly? Cleaned. All the O files. I only cleaned the... One of the frustrations about this is because it defaults to 26-bit, it only cleans the 26-bit versions unless you tell it that you're building 32-bit. Really need to update my build environment. There we go. Now we'll actually rebuild everything. That's more like it. Wrong number of parameters to disassemble memory. At 245 and 336. Nope, not that one. Make the window smaller. Are you not going to make it smaller for me? Come on. Oh, for Pete's sake, come on. You're there. Oh, the pointer's actually there. Look, now I'm dragging the window. Something's a little bit messy with these, with the pointer on this, and I'm not sure what's going on. Stop it. Right. I don't like you, but I'm going to go and... If I drag that... there. No, you're still dragging the window. What are you doing? No, still dragging the window. Right, okay. You sit at the top, you sit at the bottom, and we'll just suffer with the fact that it's a little bit screwy. Oh, now you're working. Yeah, okay. I threatened you and said, well, I'm going to settle for it. It's definitely something odd with the how the screen capture interacts with things. Anyway, that's a different problem. I need to get back into Veneer, and I need to look at line 245. Yeah, so we're not passing in the annotation function. Oh, that's the that's memory A. Should memory? Oh, that's a problem for another time. And line 336, which is memory I. Good. At the moment, they won't do anything. Yeah, just memory I. There we go. Cool, we don't crash anymore. That is much better. So with that crash out of the way, we just need to add in some code that will do breakpoint annotations. So let's have a function, breakpoint annotate. Find a address of a breakpoint and annotate it. What do we need then? We want the instruction, I suppose. So this is value equals the instruction to decode, and it returns either pointer to a string if annotating, or null if not. Const char star breakpoint yeah, except that's not the syntax that we have for the breakpoint annotation, for the annotation function. The actual syntax is address equals address of instruction. Data points to the instruction data. Size equals the size of the data. Address int 8 star data in size. Okay. Adders. If size is not equal to 4, then no, not arm. So if, okay, so we need to know what the word is, don't we? So uint which we just happen to know that it will be at the moment, so it'll be fine for the code we've currently got, but it could be a problem in the future. Hash define break, but what code is this? Define but mask is e what no ff. Oh, I can't remember. Give me a second. 20. Oh, 20 is aligned. That's good. So it is actually FFF. 0, 0, 0. 0, 0, F, 0. There we go. If value and mass code. Let's put some brackets around that to make it clear. Actually, no, if it isn't opcode, we can return null. Not a breakpoint instruction. We want to know what the number is. Number equals put extract from. I should probably use that in here as well, shouldn't I? Put code. There we go. And then put extract. Extract, sorry. Value. Right, so it's going to be value and F. Or value. Yeah, just show you this over here. So it's all bits from 8 up to well, up to 19. So value shifted right 8, shifted left 4, and that wants to be and OX 1, 2, 3, 0. And then bracket closing that. And number value should also be in brackets because this is a parameter to the macro. Okay, so that'll get us the number. I should really say that, shouldn't I? Check the number from the instruction. I should probably actually call it the breakpoint instruction instead of trying to just say bookput. It would probably make a bit more sense. Right, so we've found the number. Now we need to find breakpoint in the list. So breakpoint t star bp for bp equals breakpoint start of the list whilst bp and bp2 number is not equal to number. This might be better in a function, you know, actually in a function that just finds it, but for now it'll do. Again, that's also the entire implementation. If bp, if not bp, if bp equals null. Actually, if not bp, makes more sense. If not BP, we can just return a, yeah, not a known breakpoint, not breakpoint. Actually, unknown breakpoint. The breakpoint's still valid. It's just it doesn't know what to do about it. And then we want to return a string that says the last value. So we need a static buffer here. Buffer. Oh. I'm going to make a big buffer. Fix me, make this calculated constant size. I don't know how big it needs to be, but we can work that out later. Yeah, and then we want to do the disassembly. The disassembly code is going to be pinching the code from the list. So sprintf there, I suppose. Sprintf old code send s. I'm not sure this is going to look very tidy, but we'll see. Oh, sorry, sprintf takes the pointer to the place where we want to write it. Buffer there. Return buffer. And that's a static buffer, so this time it should be safe. Right. That's now present in there, so we can add it to the header. And we want to call it from the where do we want to pass it in? We want to pass it in the veneer, I think, don't we? Yeah, I think it wants to be in the veneer. Memory I. So if we pass in breakpoint annotate there, let's put it on a new line. I think that has the same function prototype. And I think we should just be able to build that. It's always surprising when things are so fast and they appear to have just worked and you weren't sure. Memory I 8000 plus 8 didn't crash. Break set 8000, breakpoint set. There we go. We've now got an annotation on there. Yes, the comments aren't in the right place. We can move them around later. But that's actually not too terrible. I'm not going to complain too much about that. So, with that done, we've now got, yeah, breakpoints. So we literally just only modified it for annotating, annotating the breakpoint. Oh, I should have tested that dump worked as well, shouldn't I? Let me just do that, because otherwise I'm going to have problems if it. Again, those should probably be in the dump I. Oh, hang on, what the file's called? Dump I debugger. Yeah, that isn't crashing. That's good. -A. Added annotations for the breakpoints in the star memory I code. Star memory I now displays the old code as a comment alongside any instruction. Oops. That was breakpointed. This differs from classic debugger, which would replace the disassembly with the old instruction as if it were there, and use a star to indicate that the instruction, that the address have a breakpoint. I'm not sure which is better. I like my version better, but that's just how I would like to see what the code is that's going to be run, not the code that was there that we're just obfuscating. So that's what I've done anyway. Right, there we go. Save that and push it. And with that, yeah, that took a little bit longer than I expected, but we all had a break. That's an hour and 40 minutes we've taken so far, so yeah, not too bad. About 5 or 10 minutes and we will come back and continue with the implementation of breakpoints. If you've got any questions about what we did here, or what's going to happen, or any other part of it, please feel free to just leave them on the chat and I will come back to them once we come back from the break. All right, thank you very much. See you in a bit. Back soon. Hello, we are back and we have pineapple juice, which is always good. And so let's have a quick summary of where we're up to. Have a drink first. So, in the middle of implementing the debug functions, breakpointing, inside the ARM disassembly module, Debugger. We currently have today implemented star break set, break clear, and break list. There are two remaining functions. There's star debug and star continue. In particular, star debug is automatically triggered whenever we hit a breakpoint, which is going to be fun. And star continue allows us to actually execute the next command along. The command that was breakpointed, instruction that was breakpointed. So that's going to be, yeah, interesting. This is where we get to the point of, I'm not sure how to do this. I kind of know how to do it, but only kinda, and that's the important bit. Unfortunately, the instructions I was looking at yesterday, didn't find. So, breakpoint instruction. Debug. Come on, I hope that gives me something. No, it's not the one. That looks more like it might be. Might be the one I was looking at previously. No, probably not. Oh, come on. I was definitely looking at some of the breakpoint instructions earlier just to check how these things work. I can't seem to remember what they were. So breakpoint in ARM v8. Let's ask about that. No, that's not quite so useful either. If I had actually made a note of it, it would have been a whole lot more useful. Maybe it's in my other browser. Just give me a second. I'm looking in the other browser to see whether what? I was on this computer, wasn't I? Yes, I was. Unfortunately, the ARM documentation is now a bit more confused. I think, is this the right one? No, it isn't. I don't know where I was looking. I'm sure I will find it later. Anyway, let's just have a look at this one. This one might be the one that I'm looking for. Ooh. That's a PDF. This is not the one I was expecting. What is a debug exception? Ooh. Well, it's very similar to what I was looking for. I wasn't looking at the 64-bit stuff. I was looking for the 32-bit stuff. Yeah, because that all goes through the different exception levels and stuff, and I don't really want to do that. Okay then, let us go back to where we were. Right, anyway. Let's get back to where we were. And pyro, yeah, there we go. So this is what happens. I don't want the trace block on. I don't want trace block on. Yep, there we go. So here we go into supervisor, and we want to do so break set 8000, and then we list it, and it now shows us that it was there, and we can tell it to run that code, and it gives us abort on instruction fetch breakpoint at 8000. So what happens is the instruction at this address is fetched, it spots that it's a breakpoint, and it goes and takes the prefetch abort exception, which means we end up in abort mode with one of the registers, one of the FSR, the fault status registers, the IFSR, set with the debug state. So the easiest way for me to show this is to fire up a Pyromaniac. Actually, let's have a look in. Yeah, disassembler dot. Here we go. So this is RISC OS Pyromaniac's directory, and we're going to have a look for the ARM exceptions, I think it's called. ARM exceptions. Here we go. So there are a number of fault status register reasons, one of which is a debug event. A debug event is a breakpoint. Strictly a debug event could be a number of other things. It could come from there. The method of entry, as it's called, could end up being set correctly to that. But that's what the IFSR is set to. So if we have a look down here, FS debug, it's not in here. Is it in emulator? It might be an emulator. Here we go. Yes, so when a breakpoint is hit, the instruction fault status register is set to have this value in it. And then we update them. There's just a special call to actually update both the address and the fault status register. And then we call prefetch abort. And this is very similar to the pseudocode that the ARM documentation would list if I could find the blooming thing. Maybe I should search for the word ARM pseudocode. ARM PSEUDO code for aborts. This looks like the sort of thing I was looking for. This is all descriptions of them. Ooh. Alignment fault. It's not an alignment fault. It's a breakpoint instruction debug event. One of them. Corresponding to occur. Oh, thank you. I wanted to actually go to the code, please. Breakpoint instruction debug events. Generation of debug events on a breakpoint instruction debug event. State control register, system control register. Method of debug entry is set to debug breakpoint instruction. Yeah, so there we go. It's kind of what it's doing. Yeah, so there we are. The fact that we're going to be doing this like elsewhere is going to make it interesting. Generation deal with bigger type strings, instruction address comparisons. Yeah, this is all pretty cool, this stuff. because you actually see how it actually happens inside the processor, of which only some of it is implemented inside Unicorn and some of it is implemented in the code that's in the emulator. Unicorn implements basically an instruction emulator. It can implement part of the rest of the system, but because I'm bypassing interrupts and how the exceptions happen, interrupts is what Unicorn and QEMU calls any sort of system interrupt, basically, whether it's a software interrupt, whether it's a abort, whether it's anything else. So yeah, anyway, going back to the code here, we've got enter breakpoint, which goes and sets the fault status register to fs debug. So we should be able to read that. So if we just go into the system control.py, here we are. Too many dots in there, but that's the right file. We can see what the actual definitions of these are. So fault status debug has the value 10 in there. The actual assignment of IFSR is another broken up thing. So one of the bits is in bit 10 and the other in the below 4 bits. It's all very weird. Anyway, the mask for it is going to be relatively simple. It's this mask here. So, why am I talking about this? Because we're going to have to handle it, which isn't a whole load of fun, as you can imagine. So that's Pyromaniac. Let us just hide Pyromaniac at the moment. We don't need it. We need our code. What we're going to do is we're going to have to add in a prefetch handler. And in order to have a prefetch handler, we have to then install a prefetch handler. So let us write some code that can start doing that. Breakpoint, add prefetch. Actually, yeah, add, install. Install is a good word. Prefetch handler. Add a handler which is called when a prefetch exception occurs. None. Returns none. Yeah, I think we'll leave it as none. So, how do we add an ARM prefetch breakpoint? Yeah, I can't spell. Breakpoint install prefetch handler. Hello, Subham Kanusia. Sorry, can't pronounce that right, I'm afraid. I'm not quite as Kanusia. Kanusia? Something like that. Hello, anyway. Right. So this is going to install it, and to do that, we need to call our claim processor vector, which everybody else will know. No, nobody knows. I'm not even sure it's in here. OS claim processor vector. I think it must be in the PRM. Claim processor vector on page 128. Here we are. Okay, so I want to claim prefetch. So we want registers 0 to 3. I need to 2. I need to set, and 3. Or yeah, that'll do. And then we need to pass it in address of the exception handler Oh, I don't need the second one. I need one address. So this is the. We'll call it prefetch handler. Oh, I probably want some error handling in this in case it didn't work. And I want some definitions here. Exception prefetch is 3 and claim processor vector claim is 1 shifted left 8 and release is 0 shifted left 8. Okay. So claim it. If we get an error, what do we do? I think actually we'll just abort kernel os error. We'll give it a return an error pointer to error or null. Okay. We probably also should have a uint 32. It should be, shouldn't it? Old exception handler, old prefetch handler, sorry, it should be equals no handler. We'll have a special marker word, which is no handler of count 1, 2, 3, 4, 5, 6, 7, 8. Because if it ever was a handler at OX40, something very bad would have happened. And I need to return that into or out 1. Ampersand old prefetch handler. Right. If old prefetch handler handler actually it's not. If it's already been set, return null. We've already claimed it. Just remember that should be LU there. If there was an error, we want to reset the old prefetch handler to be no handler and return the error. Yeah, we'll return the error. Otherwise, the prefetch handler is set and we are good. So, when we set a breakpoint, we should try and install the handler. In fact, we should try and install the handler first, because if we can't install the handler, then there's no point in us changing the instructions. So, install prefetch handler. Whoops, that was not right. Error return. Install handler. There. If we got back an error, return it. Okay. And then when we're clearing the handler, if no longer breakpoints, remove the handler. breakpoints remove prefetch handler. Oh, only if we've got no breakpoints. So if no breakpoints, then remove prefetch handler. If we got an error back at this point, so that might happen if somebody else has installed a prefetch handler and after us, and we try and be removed first. It can't handle that. The interface is not allowed for that particular operation. We'll return that error. But the breakpoint will have been removed and there'll be nothing left. So we'll be sitting on the error handler, but it won't actually be able to do anything. So that'll be, yeah, quite bad, but not fatal bad. So we now need to install, actually write the remove prefetch handler. That's going to be very, very similar. I could potentially have the two functions do the same thing, but two functions with a register or a deregister or something. But it then becomes more complicated code. If we don't have a handler, then we're good. This time we are doing a release, and we need to pass in the old handler so it can check it. It's not a brilliant interface, but it's not a terrible one. I mean, yeah, it does the job for a single handler. If we got an error, no, if we got an error, then we return the error. If we didn't get an error, then we no longer have a handler. And we're good. That's excellent. So these two functions need to have prototypes in the header file now. So let's go and add those into the breakpoints header file. And put semicolon into that. And back to where we were. And the other one, please. Ooh, I've clearly been far too technical or boring because we're down to just 2 viewers apparently. Dear me. Oh, that's interesting. That means I didn't change the function name. Anybody watching this in the future is going to go, you only got 2 viewers? Oh, how crazy is that? You're now a multi-millionaire from all the revenue you got from this. Oh, look, flying pigs. No, I'm not very funny, I know. Right, there we go. We've now got the install prefetch handler and the remove prefetch handler functions in there. So we should be able to try and build this. It should fail. Oh, we're in Pyromaniac, stop it. Go back over to the debugger window. All right. Oh, we haven't included swise.h. So it's possible that we should actually separate out the prefetch handler into another file, but for now it'll do. Right, so we haven't got this function prefetch handler because we haven't written it yet. So the prefetch handler is entered in abort mode, and therefore we can't use the CMHG header file, generated header file for it. I'm going to need to write a little bit of assembler for it, which is always fun. So in order to do that, let us, yeah, we need to, and we need to have a header file that defines it. So let's just define what the prefetch handler is. New file, prefetch, yeah, prefetch, please. Declar in capital, oh, it's called prefetch, sorry. declaration of the exported assembler to handle prefetches, prefetch aborts. Oh, this isn't a function definition, it should be a file definition, you fool. Fool! No. That key. I know which keys to press. Prefetch. Let's just pinch that text as I've already written it. 21st already. Well, same as it was earlier today, but still, it's the 21st. So this is the complicated bit of the code, I think, and I am wholeheartedly expecting that I'm going to make some insane mistakes in it. But prefetch handler, there we go. But we will see how it goes. Dum dum dum. There's prefetch handler header file. So now I want to create the S file. I've already got a S directory for stuff we didn't actually need to be in assembler. Prefetch. Okay. Since we've already got an assembler file, let's pinch the beginning part of this, since we're going to be doing pretty much the same thing. Export. Prefetch handler. And oh, that's interesting, isn't it? I want to call the old prefetch handler. So that old prefetch handler that I got back, I need to have so I can pass things on. Oh dear. Said Pooh. Let's write the code and then we'll work out how to tie it together. Because this is going to be, yeah, as I say, it's going to be, I think it's going to be complicated. I'm not really expecting this to go so well, to be honest. Okay. Very quickly. Prefetch handler is entered in but mode. SPSR contains the old mode and processor registers and processor state. SPLR SP but is in use, which is interesting because we haven't got an abort stack in RISC OS Pyromaniac, so things are not going to work. Might add an abort stack, which is going to be interesting. We'll do that in a second. Is in use. SP underscore mode contains the SP on the old mode, and LR underscore mode. Oh, LR contains the old PC. Actually, does it? Or do we have to use the IFAR? I think we should use the IFAR. Yeah, I'm pretty sure it's the IFSR contains the status, which will be 0 shifted left 10 or 10 0 0 1 0 shifted left 0, which the breakpoint will be that. R0 through R12 contain the registers time of failure fault. That's right. Okay. So, first thing I think we want to do is we want to store all the registers so that we can preserve them. And there will be an abort stack, there just isn't at the moment. Let's use, okay, so what we want to get the address of R0 of the, there's a register, an exception block called the breakpoint exception block, which is I think what we should use. I'm going to just load it. Load exception dump. So get the address of the exception dump and then store IB R0 through to R12. R1 through to R12. Exception dump. Store R0 there. And R14. Now, I want to look at the IFSR to check what type of exception we've got. Actually, do I even want to do that before I've... It'd be better off to do that before I've even checked the exception dump. So, how do I get to the IFSR? I can't remember. But I've implemented it before. IFSR. That's the IFSR. Read IFSR. This one. Or is that the AR? I can't remember. Which one's which? One of them reads the IFSR and one reads the IFAR. And it's AR first and then SR. AR in 0 and SR. Okay, so read IFAR. Go back over to here and we'll just leave it as a comment. Read IFAR, and the other one, oops, no, wrong file, this file please. Oh no, I got the wrong one, didn't I? I've just done, that's right, oops. That's read IFAR, again. Have I done it wrong again? Yeah, 6 and then 5. Oh no, that's DR. Oh, come on! Read the blooming instructions here. Right, this one. Go back to here. And the second one. Yeah, I'm getting myself confused now, aren't I? Here we are. Is this one. Read IFSR. No, I don't want that. Don't want that. That's that one. Too many blooming files. Read IFSR. And relax. Right. Find my instructions. The one I care about is reading the IFSR. And that reads it into R0. R0 equals IFSR. And R0, comma, number, IFSR, false status, mask. And that value is 0 shifted left 10 or no, 111 shifted left 0. And IFSR FS debug, which is the one we care about, is 0 shifted left 10 or oh no, it's mask, it's set, sorry, I apologise. 0010 shifted left 0. Yeah, great. So and R0 with the mask. And then we compare that to technical number. Yeah, IFSR FS debug. BEQ is a breakpoint. If it's not a breakpoint, however, we need to get ourselves into the old exception handler. So to get ourselves into the old exception handler, we need to restore all the registers back to how they were and then jump to that address, which should be easy. Somebody remind me, is there a separate link register for each mode? Have I forgotten too much about ARM32? Registers banked. Yes, they do. Yes, they do. Okay, so yeah, I was overthinking this. R14 is not relevant in this instance. So what I want to do is LDR R14, no, LDR PC, comma, old exception, old prefetch handler. Do LDM FD. Probably didn't need to store R14 there. R0, R14. Yeah, and here we've got a breakpoint. I'm not exactly sure what I want to do here. So what I am going to do instead is mov PC, number 0. Because if we hit that, we know that we've actually recognized that it was a breakpoint. Yeah, that's super tacky. Right, get rid of this. We don't need that at the moment. We do need the old prefetch handler to be available to us. So I'm going to stick it just here in the actual code, just because it's not possible otherwise to try and do it. 0. This will mean that we can't be running ROM, but I'm not sure that it really matters in this instance. Initially, it doesn't really matter. All I'm trying to do here is just demonstrate that we can actually get something. If we can get something, then we can finesse it a little bit later. I am going to need to export this. Actually, let's do it a different way. Let's do this as prefetch handler workspace, and we can have address 0 as being the that's like there. Old prefetch handler. Yeah, I mean, this will need to be kept in step with the other code, but I think this is okay. You can tell I do not like writing assembler code. Although, to be fair, writing prefetch handler is probably one of the more complicated things that you'll ever have to do. Into the header, right? Extern void prefetch. Oh no! Why not do get prefetch handler workspace there and have it return a type structure? That's a better idea. Def struct prefetch workspace t uint 32t old prefetch handler. Stood int h. Yeah, so now I need to implement this function that will do the actual reading of the address of the get prefetch handler workspace, which we can do just by shoving it in here. ADR Okay, and now if we're up in breakpoints, old prefetch handler here is this, but we also want to actually remember it if it was successful in there. So we want to do get prefetch handler workspace, and that goes into prefetch to old prefetch handler. Oh dear God. Why do I take on projects like this? Sorry, are you missing a star in the declaration since it's a pointer to the workspace type? In the pointer declaration? You're meaning in the prefetch? .h. Let me have a look. Probably I do. Yes, I do. Thank you. Top. So that gets me a prefetch handler workspace. Yeah, thank you. Cool. Let's try building it and see what happens. Not really. I don't think included prefetch. Yeah, it's nice having other people actually comment on things and say, you missed that. It's a little bit of pair programming that is quite nice to see. I was wondering actually, I don't know if this is the first time that, certainly the first time I've ever come across it, any time that somebody's done RISC OS type coding online to sort of show people how you do stuff and maybe screw up badly and stuff. Need to update the makefile. Makefile for the module. Just need to add in prefetch into there. Okay. Yeah, some of that was valid code. So first things first, these are different representations of it. The assembler here doesn't support the number syntax on that, and this is just plain garbage. It's a bit weird how little RISC OS content is around, really, says Spanners. He's also suggesting that we use chat DPT, which is his initials. It's quite cute. Right, let's see if we can compile that. Battle friends. Is it complaining about the OR? I thought that was valid. Is it complaining about my binary? Does it need that to be OB? I don't know. Immediate value is out of... Apparently it didn't understand either of those. I wonder if there is a... There probably is a syntax. I'll bet I know what it is. It's probably this. Because it's RISC OS, isn't it? Yes. Okay. Right, so undefined symbol, old prefetch handler. Well, actually, that's just... That'll do me. As long as it's not too far away, that'll work. And this, I can't get that value, so... There we go. I knew there would be a reason I'd need R14. Equals... IFSR mask. Yep, missed that one. Come on. Get prefetch handle workspace. There is a very strong likelihood here that this will not work. Break set 8,000. Ooh, didn't crash. I like not crashing. Go 8,000. Ooh. Oh, yeah. There is no stat. I'm pointing to the screen. It doesn't help you. There is no stat pointer in abort mode. I think I said earlier that we don't have an abort mode yet. Abort mode stack in Pyromaniac is true. So let's install. So not only are we going to be writing assembler and C, we're going to be editing the operating system to make sure it actually has the right stacks as well. So let's do that. Kernel.h, not h.py, sorry, kernel.py, there we go. Right, so I went and checked this earlier and I did see we have no abort stack. So let's go and implement it. So after going into RQ mode, we'll go into abort mode and we'll create an abort stack. Dum, dum, dum. Yep, there we go. Now we need to go and that'll assign the stack to the right to the end of it. So up here at the beginning of the memory initialization, we create a number of dynamic areas. Let's just scroll this down a bit so we can see a bit better. Here we go. Yes, we initialize the dynamic area system, and then we read the configuration for the memory map, and then based on the memory map configuration, we build some stacks, of which we should be also setting the stacks, the flags properly, but we don't. So we've defined an undefined stack, but we haven't set up an abort stack. So let's go and set up an abort stack. Unlike classic RISC OS, every area of memory that exists in a dynamic area. Classic RISC OS doesn't do this. RISC OS Select was moving heavily towards having every area managed in a dynamic area. And the point is that if they're all in dynamic areas, they are significantly easier to manage and enumerate and just control in memory. And the nasty behavior of the kernel to sort of fix these up after the event is really a like RISC OS 2.3ism, because dynamic areas came in RISC OS 3.5, at which point there was larger memory available on a 4K page size. But all of the areas that have previously been like magic, like the cursor area and a bunch of others, the SVC stack, the IRQ stack, those were all just areas that magically came into existence. And there's a little table of this is what the areas are. These are magic. Doesn't quite say that, but they are. That's just awkward. It means you've got this environment early on where memory exists, but it doesn't have any real logical position. And you've got later on, you've got this place where most memory areas can be enumerated through OS dynamic area, but there are some that you just have to know exist. And that's another reason why OS reads sysinfo, whatever number it is that reads the kernel values, exists. It's a whole collusion thing because this side of the dynamic area stuff has not been managed properly. Anyway, that's enough of my complaining about how badly designed RISC OS is, or at least RISC OS Classic is. There's a better design here, I feel, anyway. So we're creating an abort stack, and we're using the memory map configuration. So we need to find the memory map configuration, which is actually, it's probably in the file memory map, isn't it? That seems like a sensible place for it to be. Oh, that's that one. That memory map file is actually the definitions. It's not the one I wanted. Wonder where it lives then. Is there another memory map? memory, constants memory map. Is it actually in kernel then? Is it in the file I was just looking at? I mean, that would be stupid of me. It is in that file. I just spun straight past it. Here we go. This is how we define configuration blocks. We declare what types the data has. So in this case, we're copying the undefined stack and we'll just create a new one. And a but. And then we're going to want to declare how it's help text. So here we go. You may notice that I'm very lazy about this stuff. I can always expand it later, that's the point. A but stack configures the base address of the abort stack area. The stack must have its base at the megabyte boundary. I don't think that's true. In fact, I think it's untrue. I'm pretty sure it's untrue. Yeah. And same goes for all of these. ABT, sorry. Maximum size. It is unlikely that resizing the abort stack at runtime will function well. Understatement there. Actually, the abort stack will probably be fine because nothing's using it hardly, just us now. And it does look like it actually takes its default values from the file memorymap.py, which is a constants file. So let's go and just enter these, shall we? Oops, too many. Abort and abort stack base size. Okay. Let's go back to the memory map constants file and we'll refine this. Oh, where shall we put it? Softcam map lives after it. We're not actually using that, so. I think I can get away with putting it just there. I mean, it only needs to be tiny. 16K. Could it just put it after the abort stack? Unstack. Oh. Unstack base plus unstack size plus 1K. Yes, so plus 4K, so it's one page between them. And we'll give it 16K, but I don't think it needs to be very much. At the moment, we're going to use like 8 bytes, so it's not really a big deal. Okay. So, with that in mind, shall we now just move that out the way? And then try and start up Pyro again. Module object has no true. Oh, we haven't got a definition for abort stack. Interesting. Well, okay then. We'll have to define one. Even RISC OS select didn't apparently have one. That is an interesting choice. So const din pi. RISC OS constants dynamic area. DA number SVC stack IRQ stack, undefined stack. Since it's a whole new one, I'm going to put it up at this area here. I need to go and get this registered. I'm not sure that dynamic areas are actually registered. I think when we talked about this before, it was just a matter of putting it into the right file. Plus change dynamic area. Area to alter. Huh. It doesn't even include the other ones in here. And I've got a whole load of extra ones that are just not used. Maybe I should just update that. All right, that's a problem for another time. So I've created an abort stack, and hopefully that will work. Let's just put that out of the way. Put this up here. Actually, rather than doing that, let's do that. There we go. System dynamic area 50 has already been assigned. Woo! Why has 50 already been assigned? 51 then. Help dynamic areas. Utility executables. Oh, I haven't registered that one at all, even myself. DA number utilities. Bad boy. Always document your work. Right, so there we go. We've now got an abort stack, which is handy. And because of that, we should be able to break set 8000 and then go 8000 and see whether this works. Actually, it did work. It just didn't recognize it as a breakpoint. Okay, so Pyromaniac debug trace. So there we go. Go 8000. That's an up call handler. Fine. Then we go into the breakpoint. The breakpoint branched off to this code. This is our executed code that reads the IFSR into R1. It is into R1, you idiot. Okay, that'll be why it doesn't work. Thank you. Right. Go back to here and change this so we actually read it into R1, R0 rather, and we might actually have a sensible bit of code. Rebuild it. Oh, I'm not going to make me under 3 hours thing here, am I? It's a bit unfortunate. Set a breakpoint. Turn on the tracing. Go. Branch through 0! It's our temporary crash, it hit it! Pineapple juice for the win. Yes. Right. Okay. Rudimentary prefetch handler. And we managed to kill it. So One of the important things about this, of course, is that I'm using Pyromaniac because it gives me more information about what's going on. I can see all the registers that are being populated as they happen. And when I saw it previously, I should have pointed this out and said what I was looking at. I noticed here that when we got to this instruction, R0 was set to something that isn't a fault status register. And so therefore I knew that it was an R0 was a problem, and I looked back up here and saw there was an R1, not an R0, and did a bit of a facepalm. So when we come down here, and the one we've just executed, we've read the IFSR there, got our mask, tried to AND it, and the value is 2. So mount it with X 2, it was 2, and then we reached our branch through 0. So that seems to be working. We can also test what happens if we go and try and branch to some memory that doesn't exist. So this memory shouldn't exist, and it still comes up with an abort on instruction fetch, exactly as you might expect. It's gone into our default prefetch abort handler. And if we look back up here, there's our code executing, and then we branch off to the special magic handler, which just happens to live in the high vector space. Yeah, cool, right. Having recognized that we've got a breakpoint, we're not actually doing anything about it. What I'm going to do here is I'm going to try and, because I'm running up to 3 hours now, I don't really want to run too much longer, but I don't want to leave it at a place where I've got kind of a broken system that is half implemented. So what I'd like to do is just do something that stores the values and prints out the fact that we are doing an exception, and then just exits and just like crashes. Because then it's not the actual code is implemented, but we're not actually dying, if you see what I mean. So that's my plan. Let's see what we can do. Yeah, so we want to dump things in the exception dump area. That was our crash. So I want to get the exception dump. That's going to be a variable that we're going to pull in. So we're going to pull it in from the prefetch handler workspace at address +1, +0 rather, +4 even. Fine. This is going to be exception dump area 16 + 1 words. So that's stored all of those. In order for us to get the SVC stack pointer and link register, we also need to go and drop into SVC mode. So I probably need more registers than just 0 and 1, don't I? That's fine, I've stored register 1. I can always pull it back. That's cool. Oh, let me actually store the register 0. So if I just do LDR R1, SP, old register 0, SDR O, R0, comma. Don't increment it there. Store R1 at R0 there. Oh, yeah, that's right. Store in exception dump area. Yeah, I'm bouncing around between. Sorry, somebody just said I'm struggling to write code using Python. You're writing in assembler. Yes, I've spent a lot of time working in assembler, and it's one of the areas that I grew up in. I wrote assembler in 6502 and BASIC and a bunch of other languages, and I've got a bit more used to just jumping between languages. Something you get used to, and the more you read it, the more you see that sort of assembly, you get to learn the sorts of things that are useful. It's a lot easier now because we've got bigger machines that can do more powerful things, but keep learning Python. I mean, it's a good language. It's my primary work language at the moment. Yeah. So I need to go. So I need to go to SVC mode. Oh, actually, no, we don't need to go to SVC mode. We need to go to. Oh. We need to go and get SP and LR from the target mode. The target mode might be user mode. If we go into user mode, we can't get back into abort mode. Whereas if we go into SVC mode, we can. We need to go to SVC mode anyway. So we need to call our module code. I'm not going to get very much of this done. It's going to fail badly, isn't it? So let's go into SVC mode. To do that, we need to do RS R1 comma bracket. Sorry, CPSR. No, it's just CPSR, isn't it? And oops, no, BIC. So clear off the bottom bits. BIC R1 comma number mode mask, or R1 comma number mode SVC 32. Oh. See, strictly, I shouldn't even go into SVC 32. I should go into SVC of the bitness of the system. Right. We'll just leave a note rather than trying to fight it right now. Mode mask is that correct? No, it's that, isn't it? Because mode SVC 32 is 2. That, I think. I'm pretty sure. I'm not sure. Registers.py. Yes, I was right. SVC is 1, 3. Not yet. Okay, it's fine. I just blanked on that for a moment. And then we want to do MSR. Oh, hang on, I also want to store the MRS R1 comma SPSR, because the SPSR needs to be stored up at R0 comma number 16 times 4. Store SPSR at the end of the register dump. Move status to register CPSR all, comma R1. Now in SVC 32. Okay. Oh, balls. That's no good. No. And R0 SP number 4 times 2. Unstack the Right. Now in here we can stack some more registers that are the SP. I need some registers, so let's just use R0, R14. This should probably be the stack sequence used by Classic RISC OS. Classic RISC OS has a particular stack sequence that it puts at the top, such that if there's an exception, it can go and pull the data back and go, this is where I was really. It's horrible. And if you don't have it, it's going to go bad. I can't remember what the sequence is. I think it's 10, 11, 14 or something. 10, 11, 12, 14. Oh, I can't remember. We should use it, but I'm not going to at the moment. Just stack those registers. Ooh, hang on. I also want to clear PSR_I. So if we're going to actually interact with the debugger, like pressing keys and stuff, it would be very useful that we actually have interrupts so we can actually do things. Because we've just hit a breakpoint, you could be in the middle of a sound handler and all hell could break loose. But honestly, you get all you deserve if you're doing this stuff. So yeah, tough luck. I need to set that up here. So PSR_I. Anybody remember what bit I is? Is it 1 shifted left 7? Or the wrong thing? I is 7. I'm actually quite impressed that I remember that. Wrong. This one here, please. Yeah, there we go. 1 shifted left 7. So interrupts are now enabled. We've stacked some registers. Store R14, comma R0, comma number. Actually, we don't need to preserve R0 because we're actually already. Yeah, that's fine. At this point, I'm not really caring. I'm just going to try and get some that works, and then we'll be good. 14 times 4. Store R14 SVC in exception dump. Fix me. May have come from user mode. In which case R14 isn't correct. I'm sure you'll be able to code well enough. It's okay. I'm sort of floundering on this area because although I know some of the stuff, this is doing prefetch handlers and the like in ARM is one of the more complicated things. And it's a very long time since I've ever written any of this. Store R14, add R0. It really doesn't matter. We've got to dump other registers anyway. SP, number 4 times 2. Store R1. This is the old R13. And finally, I need the IFAR, which was that instruction there, in order to put that in R15. Actually, I could have done that from abort mode. Since I could do it in abort mode, I probably ought to. I've done all the other FSR stuff in there. Yeah, we'll do that there. str r0, comma bracket r0, comma number 15 times 4. The trick is to drink 2 pints of pineapple juice, just juice, in an hour. Yes, that is clearly the solution. Although I have heard that people drink other things. Store R13 in the exception dump, and then after we've stored the R13, we've now got R0 through to R12 done, R13, R14, we've stored R15 and the SPSR, so they're all dumped, and we can now do whatever we like, such as ADR R0, comma, GOS. So, oh, and we'll print a message actually. We might as well just print a message. Swy test. It's a breakpoint. Deep. Okay, we haven't initialized the prefetch handler workspace, so that needs to happen. And honestly, God only knows whether this is going to work. Oh, and we haven't got any SWI numbers assigned here, so this is going to fail. There's a comment here that says, I learnt that a null dereferenced pointer caused Windows outbreak because of the CrowdStrike update file with all zeros. What do you think about how this caused a break? Oh, I can't see the next thing. There we go. To break the OS. Arguably, it shouldn't have broke the operating system, but in the case of CrowdStrike, they're there to try and prevent any sort of low-level attack. So they're at the level that they're trying to prevent things against. And if the operating system could trap that sort of exception, then that would be really good, obviously. But it does have problems because anything that's crashing at that point, you really want it to die badly. Because otherwise it could be somebody trying to do something malicious. So I think the most important part of this is CrowdStrike have been given a whole lot of privilege by being able to do things at that level and to provide protection to people, and they have abused that. Not abused that. They've destroyed a bunch of that trust by causing exactly the problem that they're being paid to prevent. And I find that quite amusing. It's a little bit, I guess, ironic, maybe is the word, I don't know. But it's definitely not a good situation for them to be in. And I would not be surprised if it causes a bunch of work inside Microsoft to try and help catch that problem, but also distrust from everybody else that CrowdStrike is actually able to be trusted with their systems. Not only did they take down relatively unimportant things like the transport systems and the like, it also took out a whole bunch of more serious systems like some of the health services, people that were first responders, people that were providing support in the government for people that have got problems with money and the like. They took out a lot of systems, and that's only in this country. As it happened across the world, I haven't followed what happened everywhere else. Big questions being asked, and yeah. That's not quite the question you asked, I realise, but yeah, I don't know so much about that side of it, I'm afraid. A little bit of a screw up on their side. But the other thing to remember is everybody screws up. Everybody makes mistakes. It's how many levels of protection you have that stop those mistakes from being serious that really matter. Yeah, that's really what I would think about that. If you think about a plane has many, many levels of protection. If you have a plane that crashes, it's not because one thing went wrong, it's because many things went wrong. How many things went wrong with the CrowdStrike update? That'll be interesting. If it was only one or two, then they don't have enough protection and they need to sort themselves out. That's my view. There you go. You get commentary on current events as well. Well, it may not be current by the time you're watching this, but yeah, no matter. I've forgotten what I'm doing. Right, so oh no, CrowdStrike. Yes, I think if we have a CrowdStrike module that just goes and crashes the system, that would be that's definitely an April Fool's for next year, isn't it? I've forgotten where I am, but I think this file is done. I now need to go and put myself into the breakpoint system and try updating this. So if we look in here, please, thank you. As well as updating the old prefetch handler, we also want to update the exception dump area to be whatever the exception dump area is. I'm sure I had a exception dump region. Introspection, that's the word I was looking for. Get exception dump area. There we are. Get exception dump area will do that. Dave says, we should note that RISC OS is a terrible, terrible model for software security, in that it doesn't have any at all. Yeah. See you, Alan. I'm sorry it's taken a little bit longer to do this. Yeah, it's a bit hard, this code. Enjoy your afternoon. I'm going to get this done in the next 20 minutes, I'm hoping, because I'm tired now. And my brain is actually starting to get a bit fuzzy. I need to set the exception dump area, and to do that we need to update the prefetch code so it has an exception dump area. uint 32_t star exception dump area. There we go. That's now populated there. It's populated here. Oh, this is going to fail. Let's just see what happens. See if it builds first, shall we? Oh, that was what I was going to do, yes. Oh, yes, that's the syntax I should be using. Sorry, I completely blanked on how you're meant to write these things. Where's CPSR all? There it is. Yeah, sorry, still thinking in old ancient ARM terms. I can't remember what the blooming calls are there. RISC OS, kitten, h.swise, grep for os, right s. No, no, it's just c:/h.swise, isn't it? Right s ox 2 1 2 3 1 os new line. I think that's 11. And what's the other one? Osly. So new line is 3. I was way out. And CI is 5. Oh, that's quite nice. We've got a little pattern of 3, 05 CLI. Inventing get exception area because I haven't included introspection in this file. Introspection page. Oh, have you? Oh no, you haven't crashed. Good. All right. Break set 8000. Go 8000. Show regs. Show regs. I'm not sure if they're right or not. PC isn't going to be correct because things, but yeah, I don't know if that's actually right or not. Let's try it a different way. Basic. Star break clear 8000. It's probably going to go. Okay. I wonder if that doesn't work then. Ooh. Oh, prefetch handler, prefetch handler. Bad process of vector release vector does not match. Star pyromaniac debug trace swyargs. Oh, it already cleared it, didn't it? Break set 8000 and then clear it. Bad processor vector. So where's the swy that returned that? That's the error handler. CLI. Plain processor vector came in with 3 and that and that, and went out with bad processor. That actually looks like it's right. Hang on, it's down here, isn't it? Claim processor vector. Address which should currently be on the vector. So those are actually back to front, I think. That's why. Let's just drop out of that. Let's do it again. Well, okay, set the breakpoint. Now remove the breakpoint. Okay, I got my parameters around the wrong way because I couldn't read. Fair enough. Basic. Star memory I. No. Break set 9000. Call 9000. Show regs. Huh. I guess those might be the right registers, but they seem a little bit off. I think we're going to leave it there because I think it's been quite a while now, and yeah, we've done a lot of work here. Add h/prefetch, s/prefetch. breakpoints. Yeah. Let's just leave a note on the S file to say where we're up to. Debug here. Git commit. Added a prefetch handler. We get instruction and preserves the exception registers for us. We don't do anything else, and we will need to add more code to handle continuing in a future session. All right. Push that. It's all sitting on the branch, so we can come back to that later. Hello, Karthik. We're just about to finish, I'm afraid. So today we've added the list handling for breakpoints, set, clear, and list, and we've added the prefetch handler to trap the execution of the breakpoints that we've added. We can now do that, and when we report a hit a breakpoint message, and then we enter the shell. There's no continuing just yet, and it doesn't look like the exception dump registers have been updated properly. Not sure that that's right. We might need to do a little bit of work on that. My plan is that we'll continue that next week, hopefully. Yeah, that's the plan. If anybody wants to try using Pyromaniac and the like, come and contact me. I'm largely just trying to get this bit of the code finished. If I can get it finished, at least having the debug stuff, we should be pretty compatible with the rest of the system. There's a lot of fix-me's lying around, but that's not a big deal. I think that's a pretty good situation to be in, because we can always sort those things out. All right, yeah, that's now come up to being 3.5 hours. I hope it's been enjoyable. Please enjoy the rest of your afternoon, and we'll see you again next week. Bye.